recording on this one. Howdy, everyone. Long time no see. Right now I'm just checking if my settings are good and stuff like that. Hopefully they are. So once I check, we'll start working on some try hack me again, completing our web fundamentals path and security. Try to get as much knowledge as we can. I created this Notions template, or like used a template and worked on this, so I have to change these. Interestingly, that's right. Hopefully, I'll move this more here. So here we go. I think this is good, and I'll do this thing. One down, two down. I'm live here, so I don't think I need to keep Google open. Just have to make sure. Now I can do the transition and show you my Notion. Let's go. Alrighty. I have to change my description on my Twitch. Give me 1 second. We are at 23 followers. Let's aim for 50 in by the end of this year. Yeah. Let me just change. Hey, we are good to go. Good part is I think with the AirPods, I'm able to actually um I'm able to actually control what I like, because with the other mic I had, it was really bad. It was actually really bad to do these things. So starting. Okay. Cool. So let's get started on Try Hack Me and see what all we can get today. 9:47 Sunday night. Tomorrow is long weekend, so I can like go a bit crazy. My goal, right now, even I'll just go on my Twitter and share. This is like what I was thinking recently, and this is what my thought is becoming a little bit more. And let's see, where is the pool? Should I do 1,000 hour? How much 1,000 hour will be? I was thinking 100, but how much will be 1,000 if I have to give every week? Every week, there are how many weeks left? Well, I will be taking like 2, 3 weeks off. Basically, can't work due to some personal stuff. Let's say 3 months, 12 weeks. Every week I have to give 100 hours. That'll be hard. I'll do at least 300 hours or 100 hours a month. And I guess sponsor or like somebody who actually helped me, not David Guetta, David Goggins. Also Bazinga from I was looking at one of the the Sidemans, right? One of those guys. Oh, Pokimane. You like that? Oh my god. Oh no mind. Still works. I respect that. This is interesting. I love getting those random likes and stuff. And let me post it on my LinkedIn. Home, home, home. My profile. Things I posted. I'll be doing this guy. What? Where is my post? I have to like my post. I love liking my own posts because it's just kind of self-love thing for myself. And alrighty, let's go. Okay, put it on D&D. Ready to go. So let's start with our HTTP in detail. And let me create this week one. This was my course I created, or things I want to do before the end of this year on how the web works. HTTP in detail. So I'll create this as a page too, and I will add more. For now, I'll just start with this. So how the web works and HTTP in detail, that's our room. Let's learn about how to request content from web server using HTTP protocol. Alrighty. What is HTTPS? Let me just remove the split screen. Is there a way I can remove the split screen here? Yeah, exit the split screen. So let's read more easily. What is HTTP? HTTP is what's used whenever you view a website developed by Tim Berners-Lee and his team between 1989 and 1991. And if you look at Steve Jobs documentary by History TV 18. He does talk about it, and I think it was Next, yeah, Next computer that was used to create that. Um, the Next is the second company Steve Jobs started after being fired from Apple. So some cool insights which you will get when you are along with my journey. HTTP is HTTP is the set of rules used for communicating between with web servers from transmitting of web page data whenever that is HTML, images, videos, etc. That's what you will get when you are along. Okay, so HTTP is basically a protocol or the way of communication used while you are like transferring data from different web pages or websites. Like HTML is basically simple text data. There is another version, it's like JSON and other things. And then there are images, videos, or like streaming, like we are doing right now. And when you type HTTPS, that's secure, which we'll talk about now. What is HTTPS? Hypertext Transfer Protocol, secure. HTTPS is a secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you are talking to the correct web server and not something impersonating it. So you might be thinking like how it actually ensures that you're talking to the correct web server is actually when you do S, right? It asks in a secure way to the DNS server that, hey, send it to this particular correct server, which is hosting this particular website. What happens is if you're not using HTTP, somebody can spoof that, hey, yeah, this is, I'm the right server. It might not be, but the S creates a certificate, and that security certificate is what used to make sure it is correct or not. What does HTTP stand for? We already know. Hypertext, hypertext, right? Different type of text. Transfer, you need to transfer it. Protocol. What does the S in HTTP stands for? Remember, secure. It's all about security at the end of the day. On the mock web page, on the right, there is an issue. Once you found it, click on it. What is the challenge flag? So we have to go to the website here. There is an issue, right? We click. If you see, whenever you go on these websites, right, you see connection is secure. This certificate this provides, right, is valid. You can check all these things. I can literally go here and check more about these things. And you can do that with any website you do. And when you see this like slash red symbol, the problem with that means that, hey, this is not secure. The communication that is happening between the web server, like the Facebook you go to, Twitch you go to, it is not secure. Somebody can see it. It's not encrypted. Somebody can see. So the problem with that thing is that a man in the middle attack can happen. So, for example, let's say you are sending a data or like a package, a old type of postal package to somebody. Now you put a proper stamp, you actually like and make sure it is sealed, so that nobody else can see. But what if instead of doing that, you took a paper basically like this? Here, I took a paper and I just fold it and I send it like this, just like folding it. Problem with that is anybody can open it, write it down, or look at it, copy some of the stuff, and like write their own stuff. Like for example, something private or personal information. That's what is basically with the HTTP, with HTTPS. This thing goes in a proper package. Like for example, like let's say if this was a whole package, it goes in a proper package, then it is like sealed, it's made secure, and with that security is that much, you can say, okay, it's okay. There's no issue with the whole thing. You can I can assure you that with the whole security. And let's go with the whole idea of what the flag is. So when you click on this, as our thing mentioned, let me just copy the THM invalid HTTP cert. And this is the security, right, of tryhackme.com, where I was going when I click. So if I can show you again, if you go here, I want to make sure it is valid, or you can do that to any website. You go here, you can check, okay, what is the organization, common name, right, of the website and the organization. Is their organization mentioned? No, not part of it. You can mention when you are buying the certificate, let's say from Google or an other certification companies like GoDaddy, you can actually like put your information. It's in their certificate, they have not put. It's like kind of you want to give it, then you are giving certain information to them. You don't want to give it, that's also fine. So issued by Let's Encrypt, that's one of the organization, like I mentioned, Google, AWS, Amazon, these guys to give it. So Let's Encrypt is one of those. Validity, there is a certain time, right? You have to keep on checking for how long the certification is valid. For example, when you get your driving license, you know driving, but you need to go get it done again, right? Sometimes after, to make sure you are driving correctly, you still are already, you are like not have not forgotten the rules, right? Similar way, right? To ensure this server which I'm connecting to right now is going to be with this company, the whole thing is like for certain amount of time it is valid. These validity, you don't have to pay again and again. It's once a year, but these like automatically they keep on getting issued and expired to make sure everything is safe. And fingerprints, SHA 256, this is also the fingerprint of the whole detail or the certificate fingerprints. Like a human, we have our fingerprints, every digital thing has its own fingerprints, and that's what it's talked about. And to get the fingerprints, you use hashing algorithm. Important you use a good hashing algorithm, because you don't want, like, imagine in real world if crime happens and there are more, let's say two people have the same fingerprint and one is a criminal, one is not a criminal, with same fingerprint, it can you can get an innocent man in the jail. Same thing with these fingerprints. Important to use the right algorithm, because there are, like with the old algorithms, two things can have the similar um, prints or very similar one, which can create big, big issues. So remember that. And you can look at all the certification fields and stuff. You can export it. I don't have to. Now let's move to the next part. Let me enter this. Let's get this valid. Cool. Now we'll go to request and response. Request and responses. When we access a website, I'll just increase it just to make sure you guys can see it more clearly. So when we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. That is where the URLs will help. So basically, what it's saying, if you want to look at, let's say, this Twitch stream you're looking at, or you want to tell your browser, hey, I want to look at this person's Twitch or this channel's Twitch video or the YouTube video, the browser asks you, okay, what is the address of this, right? Just like if you go to a carnival or to a restaurant, hey, I want to taste this restaurant's food, you have to go to that restaurant. Similarly, to find the data, to look at the assets or the content of the server, you have to go to that URL. URL is basically the address of a virtual world. So What is URL? Uniform Resource Locator. If you have used the internet, you have used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all its features. It does not use all features in every request. So here are some of the features, right? I'll just put it up and let's compare it with our current one. HTTP scheme. So scheme is basically like a protocol you want to use, right? You can have HTTP, you can have, or you should have HTTPS, you can have FTP, you can have, which is for file transfer protocol, SSH, and stuff like that. So you first tell the protocol you want to use, then user and password if needed. This is what is used for SSH. You type SSH, user and password, or FTP. Also, some of them have that, but a lot of them don't. Like for Facebook, you don't have to put it here. At then the viewer or the domain, the name of the web server. So tryhackme.com. So you can see here it's the same port. Oh, we can actually increase it. Cool. That's nice. So port number, when you don't give, you are giving for HTTP is port 80 by default. That's why if you see here in our example here, it is HTTP and port is already 80, but for HTTPS it's 443 a lot of times. So, and you can change the ports, of course, but so when you're using the protocol, a lot of times already goes to the default port, which are defined in the system. And then you type the path, so view room, or like, okay, I want to go to this part. So for the in our case, we are going to a proper room, and these rooms. So like when you go inside a hotel, or let's give even a better example will be a big mansion. When you go inside a mansion, you'll have one big room, then you will have another room inside it, right? Like a bathroom or stuff like that. Same thing here. We have this room, then we have another room inside this room, or the path. We have another path inside the main bigger path. And then you have like mostly other type of query, like any query you want to ask or any data you input. Then the fragments, right? The fragments will be basically how to say which part of that exact page where you want to go. That's fragments. So let's go more in detail. So scheme, this instructs on what protocol to use for accessing the resource, such as HTTP, HTTPS, FTP, file transfer protocol, stuff like that. User, some services require authentication to log in. You can put a username and password into the URL to log in, like admin, stuff like that. Then host, the domain name or the IP address. IP address is actually like those numbers 122 dot something dot something, right? Or even IPv6 to wish to access. So these are basically the address of the server in the virtual world or the world of internet. Then there are ports. Port is basically, like in your house, you have various like windows. One window will be for your parents' room, one window will be for living room, window will be of this room, that room. Similar concept. There are many ports. Like in your computer, you will have USB, HDMI, same thing. Different ports are used for different things. So in this case, we are looking at port 80. The port that you are going to connect to is usually 80 for HTTP, 443 for HTTPS, but this can be hosted on any port between 1 till 65535. Why 65535? If you go 2 raised to power, I think 2 raised to power 12, 13, something. No, 1024 is 10, then it's 2048, 4096, 8, 16. So 2 raised to power, I think, yeah, how much? 60, 2 raised to power 16, yeah. So 2 raised to power 16 minus 1, I think that's the number. So the path, the file name, or the location of the resource you are trying to access. So which resource? Like in Facebook, you can be accessing your own timeline, accessing somebody or some other person's page or a page of a company. Here we are using going to the room and inside the or this path and a particular part even inside this part. The same thing. Then query string is some extra bit of information that can be sent to the requested path. For example, blog ID 1 would tell you the blog path that you wish to receive a blog article with the ID of 1. These extra information is used in a lot specifically for APIs to tell, okay, what exact we are looking for information. Sometimes it's even used for like username and password, which is very bad, but well, internet is not safe to start with. Fragment. This is a reference to a location on the actual page requested. This is commonly used for pages with long content and can have certain part of the page directly linked to it. So this is viewable to the user as soon as they access the page. This you might have seen if you ever used in web development something called IDs, right? And those IDs you can just, if it goes like this here, task 3 will be ID. So for example, this request and response, this, if it has an ID, like task have an ID, I can just say here task 2 and it will open if it had an ID. It does not clearly, so we can't do that. But you will see a lot of this. Making a request, this is how the request response architecture works. It's possible to make a request to a web server with just one line, get HTTP 1.1, right? The request method, the HTTP protocol version. So get is the request method and protocol version, the page being requested, right? You add to the TryHackMe. These are the pieces of information. But for much richer web experience, you'll need to send other data as well. So you can ask like, hey, give me get me, I want to create a request. So it's like, what is the smallest sentence in English? Go. You won't get anything back, or you won't get any like good information. It's a simple command, a small. But the more information you want to get, you create a better sentence. Similarly, you create a better request if you want to have that. This other data is sent in what is called headers, where headers contain extra information to give to the web server you are communicating with, but you will go more into this in the header task. Example request get HTTP1. This is the root path here. Host tryhackme.com, user agent, Mozilla Firefox, referrer, tryhackme.com. I have no idea what referrer is, but let's see. To break down each line of this request, line 1, this request is sending the get method. More on this in the HTTP methods task. Request the home web page with root or like just a slash and telling the web server we are using HTTP protocol version 1.1. One sec, I'll just drink some water. So basically, line 1 is like saying using the get method in HTTP protocol version 1.1, give us the root page, give us the page on the root directory of this web server. Line 2, which is the host one, will tell the web server we want the website tryhackme.com. Line 3, we tell the web server, this line 3, the user agent one, we tell the web server we are using Firefox version 87 browser. Line 4, we are telling the web server that web page that referred us to this one is this. So refer basically means, okay, which page led us to, or from where we got this link to this page. Line 5, HTTP request always end with the blank line to inform the web server that the request has finished. So invisible line here on this side of the request. So example response will be HTTP version 1.1, 200 is the status code of HTTP. Once you get into programming, you will learn this, but it's important to understand 200 means everything went okay. That's why the next thing you see is okay. There was no error. 200 is good, majority of the time, or all the time, I will say. Server, okay, what was the server version, right? Nginx was the server version on the web server, a server used, and the version is 1.15.8. Date, Friday, 9th of April 2021. Oh, that was long ago. 13:34:03, which is like military time, so that's 1:34 p.m. and 3 seconds, and this is GMT. Content type, text and HTML, so no images, nothing, just basic text HTML page. Content length, 98, how big the content was. This is the whole content starts. HTML, the head, try hack me, body, welcome to tryhackme.com. That's it. That was done. And here you will see one more. The breakdown of each line of the response. Line 1, HTTP 1.1 is the version of HTTP protocol the server is using, and then followed by HTTP status code, in this case 200 OK, which tells us the request was completed successfully. This tells us the web server software and version number, the current date, time, and time zone of the web server, right? This is the time zone of the web server. The content type header tells the client what sort of information is going to be sent, such as HTML, images, videos, PDF, XML. So with the content, you can have like different types. When you go on Twitch right now, it is a video streaming, right? It will be different than compared to this one of text and HTML. Next, line 5, I guess. Yeah. Content length tells the client how long the response is. This way we can confirm no data was missing. So what happens is, in real world, right, you don't send all the data as big chunk in one go. In reality, it's divided into small requests. If you have a whole, if this was your whole request, it was divided actually, let's say, in 4 different parts. Now every single one was sent. When these was being sent, you like, there might be a case like when these four were being sent, right? Like these four were sent. Only, let's say, all three went, but the one here, this was not. The person did not got it. The requested server did not got it. So what will happen? It will say, hey, we have got like number 1, 2, and 4, not the third one. Send that again because there are some content missing. So that's how it verifies that how what happens in the back of this. And to tell number 3, there is like data, extra data being sent. HTTP response contains a blank line to confirm the end of the HTTP response. Just like I said here, this is nothing is here, just a blank line. Just like in sentences, we have semicolon, colon, whatever, like full stop. Same thing here. Line 7 to 12, the information that has been requested, in this instance, the home page of tryhackme.com. So let's get into this. What HTTP protocol is being used in the above example? So we know HTTP 1/1.1. Boom. What response header tells the browser how much data to expect? The response header that tells, I don't remember. I have to see the request. Let's try to remember. Do you remember like what was exactly the header term? Can you type in the chat if you remember? I'm just thinking. Can't remember. Response header tells the length. L-E, response length. RESPONSELENGTH, maybe. No. Do you know? Can you put it in the chat if you know? I don't remember the answer for this one. I want to go up. Oh, content length. Okay, cool. And one sec. HTTP method. HTTP methods, right? HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we'll cover the most common ones. Although mostly we'll deal with the get and post method. Yeah, I deal with four basically. In my life, I've dealt with four most of the time. One is get, which is to get just simply get the information. Second is post to make any updates. Third is no, post is send. Put is to make any updates. Delete is for deletion. So those are the ones. So get request, right? This is used for getting information from web server. Post request, this is used for submitting data to the web server and potentially creating new records. The post is hard example, like creating a new student in the student ID and stuff like that. Put request, this is used for submitting data to a web server to update information. Delete request, this is used for deleting information records from a web server. So basically put is updating the student's information in university database. Delete is to delete one of the courses or one of the employees information once they leave, right? Answer the question below. What method would be used to create a new user account? Another thing I will like to say, if you're watching this, right, thank you for watching the stream. But like, keep on putting the answers in the chat. I can see, so it will be nice. Like, you will also learn. That's a good way to learn. So, what method should be used to create a new user account? To create a new user account, we need to have post. That's for creation, right? What method would be used to update your email address? Remember, there are only four big ones, right? Post is for adding, get is just for get, delete is to delete. So there is just one left, which is put. What method is used to remove a picture you have uploaded on your account? I think that's very obvious. DELETE, delete. Next one will be used to view a news article, right? Just like viewing tweets and stuff like that, same concept. Next is HTTP status code. These are very important for anyone in who is touching the internet, kind of. This can help you like debug or troubleshoot a lot of things. So let's get into that. HTTP status codes. HTTP status codes. In the previous task, you learned that when a HTTP server responds, the first line always contains a status code, informing the client of the outcome of their request and also potentially how to handle it. These status codes can be broken into five different ranges. Basically, status code is like, hey, this is what happened. If it went okay or not. If it did not went okay, what was the type of error? Basically, that's what it is, which gives us a little bit of hint as a developer or an engineer to find out what to do next. So first range is 0 to 199 information response. These are sent to tell the client the first part of the request has been accepted, and they should continue sending the request rest of the request. These codes are no longer very common. I have never seen 100 to 199, like never in my life. I have done a 4 year degree, I have 2 years of experience, never seen this code. 200 to 299 success. This range of status codes are used to tell the client the request was successful. 200 is one of the most common ones you will ever see. I can show you right now actually. Let's go here, network. Let me make a call here, right? It's taking, see post, right? You can see the status code is 200, 200. You can see other codes as well, which is 204. I'll show you, right? 204. So request went successful. Basically, if it is in this range, everything was success. 200 is success, is still pending. I don't know what's happening with that. But 200, 200 post, get, lift, free flight, stuff like that, methods, right? So that's it. Status code, it was successful. 300 to 399 redirection. There are, there's 201. Can I just check if there's any other? No, 204 is the max. So you got the idea basically. 300 to 399, these are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. So what happens is, let's say when you are on Facebook or Twitter, you click on a YouTube link. So that redirection happens where from Twitter URL or Twitter website you go to YouTube website. So that what happens here. Next is 400 to 499, used to inform the client that there was an error in their request. An error is like can happen in different ways. This can be a authentication error, authorization error. Authentication is basically who are you? Authentication is should you be on this or should you have access to this? Yeah, I know who you are, but should you have access to this? Stuff like that. And it can be 401, other types error too, like network error, stuff like that. And then 500 to 599 are the worst ones, in my opinion, because I have dealt a bunch of them and that's that. This is reserved for errors happening on the server side and usually indicate quite a major problem with the server handling the request. Common HTTP status codes. So there are a lot different HTTP status codes, and that's not including the fact that application can even define their own. We'll go over the most common HTTP responses you are likely to come across. So, interesting thing to know here is that different applications can have their own HTTP status codes, but mostly they use some kind of already in play framework. Like, for example, if you are on Java, you might have heard of Spring Boot or Tomcat and stuff like that. All the Nginx and like Python has a bunch, right? So a lot of them will use those standard codes, but some application can have their own HTTP status code, which is pretty much if you do it, you should go to hell. You should burn in hell because this creates so much of more problems. Life is already full of problems. You should not create more. 200, okay, that's the best one to get. That's like getting your crush having a crush on you type thing, and you both are in relationship. That's the 200. That's how it sounds. Request has been completed successfully. This is what we wanted. This is what we got. 201, created. A resource has been created. For example, a new user or a new blog or some kind of new, like in this case, right? When we refreshed, we saw in the network file, let's do this one here again, and we'll just do the status code here. You'll see 201 will be coming very soon. Let's keep on going up. There will be so many more coming. So this was recently created and you will see that 201 happens in this example itself. Okay, in this time it did not happen. Never mind. But mostly this 201 is created for this like extra server, extra application created. 301 move permanently. This redirects the client browser to a new web page or tells search engine that the page has moved somewhere else and to look there instead, right? For example, let's say um, Facebook bought domain like Meta, it became Meta, and they want to move everything to meta.com instead of facebook.com. 301 will be used. 302, similar to above permanent redirect, but also the name suggests that this is only a temporary change and it may change again in the future. So tells like, hey, it changed. We have changed Facebook to Meta just temporarily. It was coming back to Facebook. 400 bad request. This tells the browser that something was either wrong or missing in the request. This would sometimes be used if the web server resource that is being requested expected a certain parameter and that the client did not send it. So example, a secret phrase was being expected, but the client did not send it here. And that's what happens. 401 not authorized. You are not currently allowed to view this resource until you have authorization with the web application, not commonly most commonly with username and password. So basically, your Facebook or Twitch accounts, user details, or banking details. Forbidden, you do not have the permission. So here it is, you don't have the authorization. Here you don't have the permission to view the request, whether you are logged in or not. Here you need to log in to make sure. Here you don't have the permission. You are not allowed. It's like, hey, you are allowed in the building, but not to this level or not on this floor. 501, 405 method not allowed. These resources do not allow, the resource does not allow this method request. For example, you send a get request to the resource create account where it was expecting a post request. So a certain type of function need a certain type of method or request. It expects that, right? Because for example, your wife expects certain things on weekend or like on different things on different holidays or festivals. Based on that, you have to change. Cannot work. 404, page not found. You might have seen this all the time. The page does not exist anymore, or it never did. 500, internal server error, which is absolute chaos. The server has encountered some kind of error with your request and it does not know how to properly handle. Why you have the server then? Kill the server. Just burn it. It's bad to even see 500 or anything in 5. Like you see 5, your day is ruined. 503, service unavailable. This server cannot handle your request as it's either overloaded or down for maintenance. You have seen this when maintenance happen, which are also pretty much happens at the worst inconvenient time. Trust me, happens to me all the time. Click the view site button on the right side, right to see what some of these HTTP status code pages look like in a browser. Okay, so click view site. Okay, let's do this here. View site. Let's see what they got. And interestingly, oh, it might have lost already. No mind. I was thinking to show you how 201 works. But so let's say 403. 403 forbidden. We have seen this a lot. 404 not found. Apache. This quest URL missing HTML is not found on the server. This was the server. Port 503. Service unavailable. The server is temporarily unavailable to service your request due to maintenance, downtime, and capacity problems. Please try again. Those all are stupid. For worst one, 503 is the worst one out here. What response code might you receive if you created a new user or blog post? So remember, if we have created the things went good, Things went good means 2. And it is for creation. It was 201. Oh, it's 201 actually. 201, not 2030. What response code might you receive if you uh, tried to access a page that does not exist? What response you might receive if you try to access a page? If you tried accessing something it did not exist, are basic 404. And let me just close this guy. What response code might you receive if the web server cannot access its database and the application crashes? If the application crashes, it should be, and like you did not, the error happened, should be in 500. So the application crashes could be 501 or 503. What response code you might receive if you try to edit your profile without logging in? You are not authorized. Headers. We have what we have read. Headers, cookies, making a quest. So let's go with headers. Not bad. Headers are additional bits of data you can send to the web server when making a quest. Although no header are strictly required when making a HTTP quest, you'll find it difficult to view a website properly. Common request headers. There are headers that are sent from the client, usually your browser, to the server host. Some web servers host multiple websites. So, by providing the host headers, you can tell it which one you require. Otherwise, you'll receive the default website for the server. So, what happens with the header, right? Or in one server, like say you have a big, huge server. I was about to say something more with the huge, but that's okay. That's what she said. You got it. So huge server can have multiple websites. A small like 2 3 people are hosting this blogging website. In the header, you can tell, hey, I want to access OXGSATs, hackerspub.org, only that website. So it will say, okay, based on the header, it will give you that my website's information or the blog or whatever. But if you just say, hey, give me this blog, all those are blogging websites, so it will give you the default. And default might not be mine, might be mine. Who knows? And these headers that are sent from the client to the server user agent, right? This is your browser software and version number. So in my case, it will be Google Chrome. A lot of time you'll see Mozilla Firefox, stuff like that, right? Telling the web server your browser software tells it format the website properly to your browser. Also, some elements of HTML, JavaScript are commonly available in certain browsers. So what happens is why it is important, because Safari has a different JavaScript engine compared to Firefox and Google Chrome compared to Internet Explorer. All those have different engines. They take or understand, like have certain of their own color coding and stuff. So it's important to get that information so it can be modified according to your browser and give a better user experience. Content length. When sending data to web servers, such as in a form, the content then tells the web server how much data to expect in the web request. This way, the server can ensure it isn't missing any data. So let's say if in the request I make a request to tryhackme.com and it says, okay, you will get a page with the content length of 120, but I only got for like let's say 100, and then I can tell, hey, I got only 100, something is missing, or this particular part is missing, and it will give me that 20 missing ones. Except encoding tells the web server that what types of compression methods the browser supports so that data can be made smaller for transferring over the internet. It's important because smaller the data, easier to transfer, less chances of error, less chances of it getting like corrupted. So it's important to have encoding there, right? Mention. That's why certain browsers, this is the reason why certain browsers are faster or better because they have a different accept coding encoding thing, a different encoding methods compared to other ones. Like Internet Explorer was the absolute worst. People hated it. Every single I am a web developer. I hate it. It's good. It's dead. Cookie data sent to the server to help remember your information. See cookies task for more information. So we'll do that in a bit. But cookies are basically some extra piece of token or expression telling the web server, hey, this request came with this cookie number. So, oh, this cookie belongs to OXDSAT or John Doe or Abraham Lincoln, whoever. Common request headers. These are the headers that are returned to the client from the server after request. So these are the response headers. We were talking about request headers before. So set cookie, information to store, which gets sent back to the web server with each request or with each request. See cookies task for more information. So just the basic cookie information, like a whole cookie number, right? Let's see. Oh, I cannot show you mine. Security. So that's why it's important, like, not to show anybody your cookie, because if you show your cookie, they will have that extra information. There's cookie stealing also going on. So that's what goes, and they are able to steal your data, or if it's just cookie, they can access your Amazon account, stuff like that. This tells the client what type of content. No, cache control. Yeah, how long to store the content of the response in the browser's cache before it requests it again. So, for example, hey, do this method or do something, or how's the weather today? All that type of like certain information which are like can be cached are very small. For how long you want to keep them, it is stored. That's why it's like when you certain information are easy to get when you are already have the browser open, but when you close the browser or restart the browser, all that information or the cache is gone, so it takes time to answer for the first, but then it's so fast. That's cache. Content type, this tells the client what type of data is being returned: HTML, CSS, JavaScript, images, videos, etc. Using the content type header, the browser then knows how to process the data. So it tells way ahead, hey, this type of data is going to come. So okay, I know this type of data is coming. I'm prepared. I know how to handle this now. Or I need these methods. Let me load them in my memory. Content encoding. What method has been used? Remember, here it was what type of methods the browser supports, what type of methods has been used to compress the data to make it smaller when sending it to over the internet. Remember, this information is the reason why some browsers are faster and some are not. Like Internet Explorer was super duper slow as hell, whereas Google Chrome and Firefox are pretty fast because of these encoding. Or this is one of the parts of encoding. What header tells web server what browser is being used? Um, I keep on forgetting these. I think browser software. Nope. Browser version. I don't remember these. I just user agent. Yes, sorry. User agent. If you know, feel free to text in the smart chat or Steam chat. I'm looking at it. What header tells the browser what type of data is being returned? Content type, right? And what header tells the web server which website is being requested? What header tells the web server which website is being requested? Huh, I had it. just lost my train of thought. Uh, you are no, I lost it. Host. Okay. Whew, what a great day. Cookies and making requests. Okay, let's complete this. We'll be doing our challenge complete. So, if you're liking this, please, if possible, just say hi or just say something. It is nice to see people. Or just subscribe, follow, whatever you like to do. Thank you, though, for watching. You have probably heard of cookies before. Yes, Oreo cookies. They are just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server. Then, every for the request you make, you'll send a cookie data back to the web server. Because HTTP is stateless, doesn't keep track of your previous requests, cookies can be used to remind the web server who you are. Some personal settings of the web for the website, or whether you have been to the website before. So, for example, cookies is a great example I can give you is like some websites have dark mode and light mode. So with that dark mode light mode thing, how when once you first time you go, it already knows, okay, the default is light mode, let's give it that. And but you set it to dark mode, and when you visit it again, right, let's say after 1 hour, it already is in dark mode, it's not giving you the light mode. And that's how it happens with the cookies. It's like that extra piece of information which is sent with with the request all the time. And with that, it is able to keep a list of all your preferences. That is powerful, believe me. Cookie, and that's why there's another thing called cookie theft or cookie theft security. If somebody is able to steal your cookie, they are able to steal, like for example, with they won't be able to do anything with like the data that if you like light mode or dark mode, but they can if you have been logged into your Amazon account, and they might have that cookie and extra piece of information like what's your credit card details or stuff like that, right? Or your what is your ID of your account, stuff like that. So it's important not to go to crazy websites because some of them can steal your cookie data of different websites, and then that's it. So get HTTP 1.1 host cookies.thm and user agent. This is this. The client requests the web page from HTTP cookies.thm, HTTP 1.1 200 OK. Server is this, date is this, content type is this, cassette, HTML data. The server responds back with a simple web page with a form asking for the user's name, right? Gets the detail, asks for the username, right? The client sends back the form with the same name set to the admin or name set to Adam. Adam? What? The client sends back, oh, name, set name to Adam. So this is the header, right? User agent is this, host, content type, length 9, 4, 5, 6, 7, 8, 9. So, and then the server cookie, important. This is the flow. This is just explaining that, right? The server responds with a set cookie header telling the client to save the data name equals Adam. So save that, and after it has saved, this is the cookie, right? Cookie is set. On the next and every further request, the client sends the cookie data back to the server. So every time now, like once this cookie is set with the name equals Adam, now as a client, whenever I send data to the server, it will always have that cookie information name is Adam. So now if any page which needs name, will be filled with this automatically. So the server then sees the cookie data. Instead of displaying the form, it displays a welcome back message, instead saying, "Hey, Adam," instead of like asking for your name again, it already has typed in the cookie. Cookies can be used for many purposes, but are most commonly used for website authentication. That's why don't let anybody steal your cookie. Whether it's Oreo cookie or your browser cookie, don't let anybody steal it. The cookie value won't usually be a clear text string where you can see the password, but a token, unique secret code that's easily humanly guessable. That isn't easily humanly guessable, so it's like kind of used hashing or stuff like that. Viewing your cookies, you can easily view your cookies in your with your browser is sending a sorry. Um, you can easily view what cookies your browser is sending to a website by using developer tools in your browser. So I hope it doesn't open on that page exactly. Yeah, you can see here as well. If I make a request, right, it will have some of the cookie information. It's here in the application. You can see YouTube have some. This is another CDN, which is Content Delivery Network, a server used to faster deliver website. And TryHackMe, I cannot click on any of these because it will have some information. But you can easily view the cookies your browser is sending to a website by using developer tools in your browser. If you are not sure how to get the developer tools in your browser, excuse me, click on the View Site button at the top of the task for how to guide. Once you have developer tools, click on Network tab. This tab will show you a list of the resources your browser has requested. You can click on each one to review detailed breakdown of the request response. If your browser sent a cookie, you will see these in the cookies tab of the request. So let's just view here. So you see we have Firefox, right? Can I open it in a okay, I cannot open it in a different website. So accessing developer tools, let's go with Chrome. That's our main. To open the developer tools in Chrome, basically how to inspect, click on Chrome menu here on the right hand side of the browser and then select more tools and then developer tools. You will have the Internet Explorer. I think it should be killed or whoever made the Internet Explorer. It's really bad. It was Microsoft's own fault. They never cared. Yeah, basically you can access your own cookies. I just go inspect as I showed, right, and how to do those things. So which header is used to save cookies to your computer? I think it's called set cookie. Yeah, set cookie. Now let's do our main task for the day, and we'll be completing our first hour of 400 hours challenge. Click the view site button on the right. This is an emulator for making demo HTTP requests. Using what you have learned from the above task, you can use it to complete the below questions. Let's do that. Make a GET request to dash room. Alrighty. Change the HTTP request method. Click on send your request. Update your GET and set parameters here. Change the URL here. Okay. So what a GET request to dash room. So we can just have room here, right? GET request to slash room. HTTP try hack me. This is the response. HTTP1 protocol, Nginx, this is the date and say, content type, content length, last modified, HTTP try hack me, welcome to rooms page. This is our flag, you are in the room. Hell yeah. Make a GET request to slash blog. and using the gear icon in the set ID parameter to 1 in the URL field. Let's do that. I'm unstoppable today. I'm too proud of myself. ID should be 1. Save that. Save that. Save that. Hold that. You see blog with the ID 1. And let's go down. Here you found the blog. Hell yeah. Let's make it happen. Make a delete request to user 1. You just copy paste this. You know how it goes. Delete. Paste. Let's see if this will work. Should not, but let's see. 404 not found. Cannot find the page. That's fine. Let's do it like this. And we're going to do it like this. Uh, the user is deleted. I want to see. So if you see the server version, well, I thought the server version changed, but no. So make a put request to user 2 with user parameter set to admin. Alrighty, let's do that. Paste put, delete this, user name, admin, admin. Wish I was admin. Username parameter set to admin. Cannot find page. Huh. Put user request to user dash 2 with the username equals make a put request. I did the put request. What do you want? This is, I don't know what I'm doing wrong here. Make put request to user 2 with the username parameter set to admin. User 2 username parameter set to admin. Oh, what? Oh, okay. There was a space in there. Here I just saw. So it should be good. User has updated. Post the username to of THM and password of let mean to login. Huh. Post the username. Okay, let's go one by one. Post username of THM and password of let mean to login. Huh. Why? The username of THM. Oh, so we have login page and post request with username is THM. Next password will be letmin and go. Let's see 200. Okay, let's go. HTTP quest master. Let me share on my LinkedIn. Let me share on my Twitter. We are back in business. Please let me know whatever you like to see next. Do you have any preference, like anything you like, in your opinion, I should do? Any room? I would love to do that. Any room, including the VIP rooms. Remember, including the VIP rooms. It did not share the ID. Ah, I don't like that. I can't even edit this. I don't like that. Uh, 1.1, but like I have to say 1.25. It's like 25 minutes. Okay, done. I need to like. I wish I could share it properly. That's the problem with the Twitter. Ickity peekity pookity poo, poo 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 poo. It's not taking that. I think I can add the image, right? I downloaded it. Oh, something happened. Clubhouse. Huh. Clubhouse is down. Interesting, boys. Yeah, I think that's a wrap for the day. Um, Tomorrow we'll be doing a lot more. Tomorrow we'll be working on putting it all together. We'll be doing that. Data HTTP in detail, how websites work. We'll be doing this. Putting it all together, DNS, other components. Oh, we'll touch PHP, maybe. Quiz. Okay. Once we do this, we'll be going gold and going into introduction to hacking with walking an application. Cool. And I'll share this tomorrow. So till then, thank you so much. See you soon and have a good day. Yeah, enjoy life. Bye. I'll change this transition. Thank you. Keep hacking, keep haunting.